Okay, I'm going to try something different. I've actually gone and pre-prepared this document, which will go through second derivatives. Okay, so let's put the slideshow on the road. Let's view it. All right, so second derivatives. It's not a hard concept. It's effectively we carry out more differentiation on things that you've already differentiated. So second derivative is often referred to as the derivative of the first derivative. Oh, sometimes I even say it's the first derivative of the first derivative. So that's the second. Okay. The notation is a couple of formats, can be expressed as f double dash of x, or this variation, which is d2y by dx squared. And that comes out of the fact that basically we're carrying out another d by dx operator on something we've already operated on, dy by dx. And dy by dx is the operation of d by dx on y. So you carry out two operations. So yeah. Now here a simple example here. They've simplified first of all the function. They carried the first derivative, and then they just carried out the second derivative as it was just its own thing to differentiate. Then they tied it up. I'm not going to bother with that in my examples. I'll make this nice and short. All right. First of all, my example, I've actually picked apart D from question 1 because this is a good example of, like, if you rearrange something first, it makes a lot less work for you later on. So you see my format, I've actually broken up this into 2 divided by x minus 3x divided by, 2 divided by x squared minus 3x divided by x squared, and then simplify that to this format. That is far easier to differentiate. This will require a quotient rule and then probably another quotient rule after that, which would be harder, at least. Okay, so then next line, differentiate that, easy peasy. Then give it one more differential to get the second differential. Okay, next example I'm going to do is 2e, which looks like, okay, well, that the differential of this first part would be near the chain rule. But what happens after that? Well, there's your chain rule. 3 comes down the front, power of 2, inside part stays alone, differentiate the inside part over here. Okay, what happens next? Okay, that's what happens. Use the product rule. So there's the product rule. So if that's u and that's v, that's u dash, whoops, go back. That's u dash v and u, and I forgot to put this do this last part correctly, so I'll just type it in, times by 2, because that's the differential of that part. Okay, easy done. All right, so some more questions. I'm going to look at question 4 because there's repetitive relationships with e to the x function, also with some sine and cosine functions, but we're not going to go past the second differential. So if I take the function and differentiate it, you just get an extra k coming out, which is why you can express it, because the first part is y. You can substitute that in and then just say it's ky. That's correct. If you do the second differential, the differential of this, another k drops down. That's why you can write it as k squared y, because that part doesn't change. Okay. Question 7 I thought was interesting because it has, as well as the second differential, it has a section for part A. It requires a trig identity and a bit of rearrangement. So we'll practice that. First of all, carry out the first derivative. So 3 comes down the front. So remember, sine to the power of 3x is really bracket sine x bracket closed to the power of 3. So, but we just write this way for simplicity. So 3 comes down the front, it's 6 sine squared x. Then differentiate the inside function, gets you cosine x. Now the differential of minus 3 sine x is minus 3 cosine x. All right. So now what they want us to do next. First of all, what I did was I recognized that they wanted a minus 3 cosine x. Both parts here have a cosine x, so I took that out the front. I also took out a minus 3. So that would take out all of this section here, so that's why there's a 1 in the bracket. This part becomes, 6 divided by minus 3 is negative 2. to end up with -2 sine squared x. All right, now to do the last part, you actually have to recognize this part of the double angle formula, in particular this cosine version of it. All right, so that's from trigonometry in year 11. All right, and there you go. Is that section. All right, now I'm going to get rid of that double angle formula, and I'm going to look at the second differential. Okay, so I made a couple of boo-boos with this one to see if I got it right this time. Okay, f double dash x equals, all right, so we're using the product rule now. So we got differential of cosine x is minus sine, so they cancel out the negative in the front, this part stays the same. All right, then differentiate, okay, this part stays the same. Differentiated cosine 2x to be sine 2x. I just realized, no, still a mistake with this. It should have a negative at the front of that part. So what can I do to correct that? I'll put it times by -1. That's what I'm going to do. Keep finding little mistakes. All right. Either that, I can go back to Desmos and correct it that way. That's how I type these out. So I'm just going to go and put a little minus in there, and then we'll just copy and paste that. So just out, and we'll just switch it out for this one. And there we have it. We finally fixed everything. All right. Okay. Well, I hope you found that useful. I'm going to leave the video here. Find my OBS back again. All right. So these take a fair while to kind of set up. And you realize I'm keep debugging mistakes. Yeah, I might do some of these in the future, particularly if I'm going to be stuck at home. All right. Take care. See you later.